Dear students, how to find out length of a curve when the curve is given in polar form? That is what we are going to discuss today. So the two formulae which we shall be using are given by these. The first formula is, let the equation of a curve in polar form be r is equal to f theta. So this is the curve r is equal to f theta, and this is the radius vector theta is equal to theta 1, and this is theta is equal to theta 2. Now we want to find out length of this portion. So formula for finding out this length is s is equal to integral theta 1 to theta 2 under root of r square plus dr upon d theta whole square d theta. And if equation of the curve is given in the form theta is equal to f of r, and we are given limits for r, then s is given by integral r1 to r2 under root of 1 plus r d theta upon dr whole square dr. Let's take few examples. Show that the whole length of arc of the cardioid r is equal to a into 1 plus cos theta is 8a. Now if it is this curve, this is well known curve, r is equal to a into 1 plus cos theta. Now we shall find out length of the upper portion and then multiply it by 2. Now since r is equal to a into 1 plus cos theta, so therefore dr upon d theta is minus a sin theta. Therefore s is equal to 2 times 0 to pi under root of r square plus dr upon d theta whole square d theta, which is equal to 2 times 0 to pi under root of, now r square is a square into 1 plus cos theta whole square plus dr upon d theta whole square, which is a square sin square theta d theta. So this is equal to 2a times 0 to pi under root of 1 plus cos square theta plus 2 cos theta plus sin square theta d theta. Cos square theta plus sin square theta is 1. So this is 2a times 0 to pi under root 2 times 1 plus cos theta d theta. 1 plus cos theta can be written as 2 cos square theta by 2. So therefore s is equal to 4a times 0 to pi cos theta by 2 d theta, which is equal to 4a times 2 sin theta by 2. Limits are from 0 to pi. So put the limits, we get 8a into 1 minus 0. So therefore whole length of the cardioid is 8a. Let's take second example. Find the length of the arc of the equiangular spiral r is equal to a into e to the power theta cot alpha between the points for which radii vectors are r1 and r2. Now in this case we are given limits for r, so therefore we shall be using the second formula, s is equal to r1 to r2 under root of 1 plus r d theta upon dr whole square dr. Now since r is a e to the power theta cot alpha, so therefore dr upon d theta is a e to the power theta cot alpha into cot alpha. Now a e to the power theta cot alpha is r, so therefore dr upon d theta is r cot alpha. So therefore s is equal to r1 to r2 under root of 1 plus r d theta upon dr whole square dr, which is equal to r1 to r2 under root of 1 plus r, take this to the denominator, so r upon r cot alpha whole square dr, which is equal to r1 to r2 under root of 1 plus tan square alpha dr. 1 plus tan square alpha is sec square alpha, so square root of this is sec alpha into dr. Sec alpha is constant, so therefore we can take it outside, so sec alpha into integral of 1 is r1 to r2, so this is equal to r2 minus r1 into sec alpha. Third example, find the perimeter of the cardioid r is equal to a into 1 minus cos theta. Let's do the first part. Now first part is similar to the first problem. So we find out dr upon d theta. Dr upon d theta is a sin theta. Shape of the cardioid is like this. So therefore total length of the cardioid is 2 times 0 to pi under root of r square plus dr upon d theta whole square d theta. Substitute the values of r and dr upon d theta. So this is 2 times 0 to pi under root of a square 1 minus cos theta whole square plus a square sin square theta d theta, which is 2a times 0 to pi root of 1 plus cos square theta minus 2 cos theta plus sin square theta d theta. Again cos square theta plus sin square theta is 1. So we have 2a times 0 to pi under root of 2 into 1 minus cos theta d theta. 1 minus cos theta is 2 sin square theta by 2. So this is 2a times 0 to pi under root of 4 sin square theta by 2 d theta, which is 4a times 0 to pi sin theta by 2 d theta. Integration of sin theta by 2 is minus 2 cos theta by 2. So put the limits. So we have minus 8a into 0 minus 1, which is equal to 8a. So length of the cardioid r is equal to a into 1 minus cos theta is 8a. Now in the second part, we have to show that the arc of the upper half of the curve r is equal to a into 1 minus cos theta is bisected by theta is equal to 2 pi by 3. Means we have to show that this upper half is bisected by the line theta is equal to 2 pi by 3. 2 pi by 3 means line making 120 degrees. So because whole length of this cardioid is 8a, so length of the upper portion is 4a, and we have to show that this length bisects this upper portion. That means length of this portion should be 2a. So we shall show that when theta varies from 0 to 2 pi by 3, s is equal to 2a. So the arc length of the cardioid from theta is equal to 0 to theta is equal to 2 pi by 3 is 0 to 2 pi by 3 under root of r square plus dr upon d theta whole square d theta, which is 0 to 2 pi by 3 under root of r square is a square into 1 minus cos theta whole square plus dr upon d theta whole square is a square sin square theta d theta. Now as done earlier, this is equal to 2a times 0 to 2 pi by 3 sin theta by 2 d theta. Integration of sin theta by 2 is minus 2 cos theta by 2. Limits are from 0 to 2 pi by 3. Put the limits. We have minus 4a times half minus 1, that is 2a. So 2a, which is equal to half of half into 4a. So therefore, which is half the arc length of the upper half of the cardioid. That's what we had to show. Let's take fourth example. Find the length of the cardioid r is equal to a into 1 minus cos theta lying outside the circle r is equal to a cos theta. So we have to trace these two curves. R is equal to a into 1 minus cos theta is like this, and r is equal to a cos theta is circle. When theta is 0, r is a. When theta is 90, r is 0. So we have to find out length of this portion of the cardioid which lies outside the circle. So first of all, we shall find out the value of theta at this point of intersection. So for that we equate these two values of r. So we have a into 1 minus cos theta is equal to a cos theta. That means 2 cos theta is equal to 1. So theta is pi by 3. So therefore required length is 2 times, because we have to find out this length also. So 2 times pi by 3 to pi under root of r square plus dr upon d theta whole square d theta. As done in previous problem, we get it as 4a times pi by 3 to pi sin theta by 2 d theta. Integration of sin theta by 2 is minus 2 cos theta by 2. Limits are from pi by 3 to pi. So this is equal to minus 8a cos pi by 2 minus cos pi by 6. Cos 90 is 0. Cos 30 is under root 3 by 2. So this is equal to 4a into under root of 3. So length of this portion is 4a into under root of 3. Now we discuss what is meant by intrinsic equation of a curve. Now if you see this figure, x-axis, y-axis, this is the origin, this is the curve. Suppose a is the fixed point, p is the variable point, and if we draw the tangent at p of this curve, so this tangent makes angle psi with x-axis, and suppose the arc length AP is s. then relation between s and psi is known as intrinsic equation of the curve. So today we shall discuss intrinsic equation from the Cartesian equation. Suppose the equation of the curve is y is equal to fx. So then dy upon dx is f dash x, which is tan psi. Now s is equal to a to x. Suppose x coordinate of this point a is a. So a to x under root of 1 plus dy by dx whole square dx, which is equal to a to x under root of 1 plus f dash x whole square dx. Now eliminate x between 1 and 2. We'll obtain a relation between s and psi, which will be intrinsic equation of the curve. Let's take one example. Find the intrinsic equation of the curve y is equal to c into cos hyperbolic x upon c. Hence show that c into rho is equal to c square plus s square, where rho is radius of curvature. Now because curve is given in Cartesian form and this is equation of the catenary, this point is 0 comma c vertex, and suppose this is a variable point x comma y. So dy by dx is c into 1 upon c sine hyperbolic x upon c. c gets cancelled, so this is sine hyperbolic x upon c. So therefore tan psi is equal to sine hyperbolic x upon c. This is equation number 1. Now s is equal to 0 to x, because x coordinate of this fixed point is 0, and here the x coordinate is x, so 0 to x under root of 1 plus dy by dx whole square dx, which is equal to 0 to x under root of 1 plus sine hyperbolic square x upon c dx, which is 0 to x cos hyperbolic x upon c dx. Now integration of cos hyperbolic x upon c is c into sine hyperbolic x upon c, 0 to x. Put the limits, we get it as c into sine hyperbolic x upon c. Now from equation number 1, sine hyperbolic x upon c is tan psi. So therefore s is equal to c into tan psi. So this is intrinsic equation of this catenary. Now in the second part we have to show that c into rho is equal to c square plus s square, where rho is radius of curvature. Now formula for rho is ds upon d psi. So therefore rho is equal to ds upon d psi is equal to c into sec square psi. Now multiplying both sides by c, because we want c into rho on the left hand side. So c into rho is c square into sec square psi, which can be written as c square into 1 plus tan square psi, which is c square plus c square tan square psi. Now c tan psi is s, so this is s square. So therefore c into rho is c square plus s square. Thank you so much.